Yes. So you can see here, whenever a body is subjected to some external force, let us take this the body, subjected to external force like this, these are the external force, it is subjected to development of stress within the body. If you take some point here on the body, stresses will be there. Sigma is there, tau is there. Isn't that? Sigma, tau will be there. We have seen that at a point in a three-dimensional body, you will be having 6 components of stress. Sigma x, sigma y, sigma z, tau xy, tau yz and tau zx. So there are functions of x and x, y, z because the stress varies from point to point. Suppose if you take some point here, stress is different here. If you take another point here, for the same loading, stress is different there. So stress at a point varies from point to point. So now here, what we do is, due to the application of this external force, this body may deform like this. Correct? Deformation will take place, there will be volume change in volume. Depending on the nature of the force, if it is a tensile force, in total net effect is tensile, then it will expand. The body will expand, volume will increase. If it is a compressive force, the volume reduces. Okay, so there will be increase in volume or there will be decrease in volume. All this we are studying in SY. So what happens here? Normally we take the 3 displacements here. So because we are dealing with 3-dimensional force system or stress system, displacement will be there in all the 3 directions. So we call those displacements as UV, W. So UV, W, they are the displacements in X, Y, Z directions. X directionally you will be having U, Y directionally V. So a point will be, after the application of the load, this P may go somewhere here, P dash. So it has displacement in X direction, in Y direction as well as in Z direction. So those are the displacements. U, V, W are the displacements. So those displacements, they are related to strains. So usually in whatever in experiment you are going to conduct in SPM lab, whether it is tension test or any other test, dial gauge we are going to fix, and we are going to note down the dial gauge reading. So the dial gauge reading is nothing but your displacement. It may be vertical deflection or horizontal deflection, whatever it is there. So when from the displacement, we can always find out the strains. Epsilon x, epsilon y, epsilon z, gamma xy, gamma yz, gamma zx. These are the strains. So just like stresses, you have 6 strains. So here, these epsilon x, epsilon y, epsilon z, they are called as normal strains. Normal strains always act perpendicular to the area, just like normal stresses. And these gamma xy, gamma yz, gamma zx, they are called as the shear strains or tangential strains. So just it is similar to stresses. So in stresses we call them as sigma x, sigma y, sigma z. Strains we call them as epsilon x, epsilon y, epsilon z. In stresses we take it as tau xy, tau yz, tau zx, shear stresses. In strains we call them as shear strains, denoted by gamma xy, gamma yz, gamma zx. That's right, that is the meaning. So just like 6 stress components, you have 6 strain components also at a particular point. Now there is a relationship between these two, that is called as strain displacement relation. You have a relationship. So that relationship is known as strain displacement relations. Strain displacement relations. This I have explained in the earlier video also. Anyway, just I will give the equations here. Strain displacement relations. So please note that this u, v, w, they are all functions of x, y, z. Functions of x, y, z, Cartesian coordinates. Because x, y, z represents point. This point, this point, this point, like that. So these u, v, w, they vary with the values of x, y, z. They are functions of x, y, z. Once you know u, v, w as functions of x, y, z, how to find the strain components using strain displacement relation. There are 6 relationships here. So because there are 6 strains, you have 6 relationships between strain and displacement. The first one is the normal strain component relationship. So these relationships are expressed like this. Epsilon x is dou u by dou x. This is simple to remember. Epsilon y is dou v by dou y. Epsilon z is dou w by. Got it? So epsilon x is dou u by dou x. So you know that strain is nothing but change in dimension divided by initial dimension. That is strain in sense of materials. Strain is change in dimension divided by initial dimension. The dimension may be length, it can be diameter, it can be volume, whatever it is. So change in dimension will come in the numerator, original dimension will come in the denominator. Alva? Epsilon is equal to delta L by L. Correct? So like that, here since u, v, w they are functions of x, y, z, we have to take partial derivatives of those u, v, w to calculate strains in elasticity. So the difference between SOM and elasticity is that SOM we are going to calculate the average value of strain over a particular area or a length, but in elasticity we take point to point, which is very important in fracture mechanics. So this u is a function of x, y, z, v is a function of x, y, z, w is a function of x, y, z. They are all displacements in x, y, z directions. They depend on the coordinates of the point x, y, z. When they are differentiated with respect to those particular directions, if you want epsilon x, u is the displacement component in x direction. We have to differentiate this with respect to x. For epsilon y, we have to take the displacement component in y direction. Displacement component in y direction is v. So dou vy, dou y. Then epsilon z, displacement component in z direction is w. So dou w by dou z. Very easy to remember. These are for normal strains which act perpendicular to the area, just like normal stresses. Then you have shear strains. Gamma xy, gamma yz, gamma zx. Correct? These are the shear strains or tangent shear strains which act parallel to the plane. Now here you should be careful here. For writing gamma xy, how to write gamma xy I will tell you. So what you do is, you denominator you write this x. First term is x plus, there are 2 terms here. Here it is 1. Like this you write. So denominator dou x plus denominator dou y. Then what you have to do is, for this x, you have to take the component, displacement component in y direction. What is the displacement component in y direction? You know it. What? V is the displacement component in y direction. Adi information. Got it? And for this, in the numerator, you have to get the displacement component in x direction. What is that? U. Isn't it? This is gamma xy. Reverse agutte. Similarly, gamma yz. So dou y I will write here, dou z I will write here. Okay? Yz I will write here. Displacement component in z direction should come here. What is that? W. W. And here displacement component in y direction will come. Similarly here, dou z, this is dou x. Displacement component in x direction. Displacement component in z direction. Got it? These are the strain components. Very easy to remember. So what they will do here is they will give this UVW as functions of x, y, z at some point, and they will ask you to find these strain components. Got it? I think a problem. So this problem we have in the other videos also. I will take up a different problem. See here, this is the problem. Yes, here. So here he has given displacement field in micro units for a body is given by x square plus y square into I plus y square plus z square j plus z square plus x square k. These are functions. When they give like this, the meaning of this is ui plus vj plus w. These are functions. First term, whatever term is there with I, that will be u. Whatever term will be there with j, that will be v. Whatever term is there with k, that will be w. Now according to that, what happens to u here? U is x square plus y square. Correct? Compare. Just compare this with this and tell the values of u, v, w. So u is x square plus y square. What is v? What is v? Y square plus z square is v. It is with j, alright? So this is vector form. It is given in vector form. And w is z square plus x square. So they may give like this, or they may give directly like this. In vector form, if they give ui plus vj plus wk is the vector form, write the corresponding functions u, v, w. If they give directly, you need not do directly you can get. Now you have the functions. You can observe that these three are displacements. They are functions of x, y, z. Now you have to find out all these derivatives. All the derivatives you have to find. Totally you have to find 9 derivatives here also. U, v, w. We have to differentiate with respect to x, y, z. That means totally 3 into 3. 9 derivatives we have to take. So let me take one by one. First I will take this u and I will write all the 3 with respect to u. That means dou u by dou x I will take. Then dou u by dou y I will write. Then dou u by dou w. Okay? Dou z. Like this. So what is the value of dou u by dou x? When you are differentiating with respect to x, we have to treat y and z as constants. Our 2x and that's all. This y square derivative will be 0 because it is taken as a constant. Then what is dou u by dou y? 2y. What is dou u by dou z? 0 because there is no z term. Similarly, I will take dou v by dou x, dou v by dou y, dou v by dou z. Like this. Dou v by dou x, this one, second one. What is dou v by dou x? 0 because it doesn't contain x term. Dou v by dou y is 2y. Dou v by dou z is 2z. Then lastly we have dou w by dou x, dou w by dou y, dou w by dou z. With respect to x, if you differentiate this, you will get 2x. With respect to y, it is 0. With respect to z, it is 2z. Got it? Correct? So these are the derivatives. Now once you get these derivatives, now using this relation, you can find out all this. Correct? The substitution for the So what he has asked at this point we have to find those strain components or strain tensor. Strain tensor will write later after finding strain components. At this point means what is the meaning of this? X is equal to 4, y is equal to 3, z is equal to minus. So what we will do here is at the point, I write this. At the point 4, 3 minus 1, what is the value of epsilon x? So epsilon x is dou u by dou x, we know that. And dou u by dou x for the given function it is 2x. And at this point its value is 2 into 4. It is, you may get positive or negative value, don't worry. We are not worried about the positive or negative thing. Numerical value is important. Next, what is epsilon y? Dou v by dou y. So dou v by dou y here is the inverse 2y. 2y means it is 2 into 3. Y is 3 then. 6. Next, epsilon z. Dou w by dou z. Dou w by dou z is 2z. It is 2 into minus 1, that is minus 2. So first 3 over. Next 3. Shear strain. Gamma xy is dou v by dou x plus dou u by dou y. Dou v by dou x. Dou v by dou x is 0 plus dou u by dou y is 2y. So it becomes 2y, that is 2 into 3, 6. Gamma yz. Gamma yz is dou w by dou y plus dou v by dou z. Dou w by dou y is 0. Dou v by dou z is 2z. That is 2 into minus 1, which is minus 2. Next, gamma zx. Dou u by dou z plus dou w by dou x. So dou u by dou z is 0. Dou w by dou x is 2x. So it is 2 into 4. Now we got all the strain components. Strain doesn't have any units. Strain ge unit illa. Unitless. Stress MPa, GPa athara irutte. Strain athara no units. So these are the values at that particular point. Suppose if the point is defined, then those values of x, y, z we have to take. Suppose if they ask you to find at the point 1, 2, 3, you have to put x is equal to 1, y is equal to 2, z is equal to 3 and get different values. So 6 values we have got now. After getting these 6 values, we have to write the strain tensor. He has asked. Just like stress tensor, we have strain tensor. Now I show you how to write strain tensor, which is denoted by epsilon ik. That is the notation used for strain tensor. Strain tensor is given by just by stress tensor. This is given by epsilon x, epsilon y, epsilon z. So these three will come in the principal diagonal. If you remember stress tensor, sigma x, sigma y, sigma z alva. ಇಲ್ಲಿ strain ಅಲ್ಲಿ epsilon x, epsilon y, epsilon z ಇರುತ್ತೆ. Epsilon x is the strain in x direction, epsilon y is the strain in y direction, normal strain. Epsilon z is the normal strain in z direction. Next ಈ ಕಡೆಗೆ ನೋಡಿ ಇಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ gamma xy by 2 ತಗೊಳ್ಳಿ. ಡಿವೈಡ್ ಬೈ 2 ಎಕ್ಸ್ಟ್ರಾ ಬರುತ್ತೆ. ಬರೀ gamma xy. whereas ಅಲ್ಲಿ ಸ್ಟ್ರೆಸ್ ಅಲ್ಲಿ ಏನಿತ್ತು tau xy ಇತ್ತು. tau xy, tau xz ಇತ್ತು ಅಷ್ಟೇ. ಡಿವೈಡ್ ಬೈ 2 ಇರಲಿಲ್ಲ. ಇಲ್ಲಿ ಡಿವೈಡ್ ಬೈ 2 ಬರ್ತದೆ. ಯಾಕಂದ್ರೆ 2 ಟರ್ಮ್ಸ್ ಇದೆಯಲ್ಲ ಅದರ ಎಫೆಕ್ಟ್ ಅದು. ಡಿವೈಡ್ ಬೈ 2 ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ gamma xz ಡಿವೈಡ್ ಬೈ. ಮತ್ತೆ ಇಲ್ಲೂ ಅಷ್ಟೇ ಸಿಮೆಟ್ರಿಕ್. ಸಿಮೆಟ್ರಿಕ್ ಮೀನ್ಸ್ ಸೇಮ್ ಥಿಂಗ್ ವಿಲ್ ಕಮ್ ಹಿಯರ್. Gamma xy by 2. First row, first column will be same. Gamma xz. Then here this will be gamma yz by 2. Second row, second column same. Gamma. So this is called as the strain tensor. So once you know the strain tensor at a point, now you know all the values. Just substitute here and get the tensor. So ಇಲ್ಲಿ epsilon x, epsilon y, epsilon z first ಬರುತ್ತೆ. epsilon x 8, 6 minus 2. ಇಲ್ಲಿ 8 ಬರುತ್ತೆ, 6 ಬರುತ್ತೆ, minus 2. ಅರ್ಥ ಆಯ್ತಾ? ಇಲ್ಲೇನಂತೆ ಗಾಮಾ ಎಕ್ಸ್ ಬೈ 6 ಇದೆ, ಬಟ್ ಇಲ್ಲೇನು ತಗೋಬೇಕು ನಾವು ಡಿವೈಡ್ ಬೈ 2 ತಗೋಬೇಕು. 6 ಡಿವೈಡ್ ಬೈ 2 ಏನಂತೆ ನೆಕ್ಸ್ಟ್ ಗಾಮಾ ಎಕ್ಸ್ ಝೆಡ್ ಈಸ್ ಎಕ್ಸ್ ಝೆಡ್ ಅಂಡ್ ಝೆಡ್ ಎಕ್ಸ್ ಜಾಸ್ತಿ 8 ಇದೆ. ಸೊ 8 ಬೈ 2 ಅಂದರೆ ಇದು 3 4 ಅಂದರೆ ಇದು ಕೂಡ ಸಿಮೆಟ್ರಿಕ್. ನೆಕ್ಸ್ಟ್ ಗಾಮಾ ವೈ ಝೆಡ್ is -2, half of that is -1. So this is the strain tensor. No units for that. This type of problem also they can give. So displacements they will give as functions of x, y, z. They will ask you to find out the strain components, and how to find out the strain components you have to write the strain tensor by using this. The difference between the stress tensor and strain tensor is in stress tensor you have sigma x, sigma y, sigma z, tau x by tau xz, tau x by tau xz, tau yz, tau yz. Whereas here the divided by 2 will be there for gamma. That's the difference. Stress tensor, strain tensor. So displacement in the strain find out part. We are going to find out the strain from displacement. From the strain we are going to find the stresses by using stress strain relationship. ಅದು ಮತ್ತೆ ಇನ್ನೊಂದು ಮಾಡ್ತೀನಿ. ಸೊ ಇದಿಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಇದೆ. ಸೊ ಇದು ಈಕ್ವೇಷನ್ಸ್ ಗೊತ್ತಿರಬೇಕು. ಈಕ್ವೇಷನ್ಸ್ ಗೊತ್ತಿದ್ರೆ ದೇ ಕ್ಯಾನ್ ಗಿವ್ ಎನಿ ಪ್ರಾಬ್ಲಮ್. ಸೊ UVW they will give, they will ask you to find out epsilon x, epsilon y, epsilon z or strain tensor. You have to do this like this. So same videos I have done, those 13 ಎಲ್ಲ ಹೇಳಿದ್ನಲ್ಲ ಕ್ಲಾಸಸ್, ಅದರಲ್ಲೂ ಇದೇ ಥರ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಇದು ಅದೆಲ್ಲ ನೋಡಿಕೊಂಡ್ರೆ ಕಂಪ್ಲೀಟಾಗಿ ಈ ಟಾಪಿಕ್ ಕವರ್ ಆಗುತ್ತೆ. ಆಯಿತಾ? ಕಾರ್ಟೇಸಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್.